Hi friends, good evening. It's Sandy. So what we are going to discuss today regarding transistors. Transistor, shortly we used to call it transfer resistors. It consists, there are three terminal, there are three major terminal, base, collector, base. Here you have to represent base, here you have to represent collector, here you have to represent emitter. See here I'm showing the number of sizes. So the variation of the sizes. See this picture. So it looks like a different sizes. The transistor has different sizes. So transistors generally have BJT types and FET types. That also I given. See the representation also I given clearly. Symbolic representation also I given clearly. For FET we have to represent gate drain source. So FET has a terminal gate drain source. For BJT have a terminal name base collector and emitter. If the here see every one of you here you have a direction. No, this the particular direction is in a inward. Then the transistor is said to be PNP transistor. If it is here, if it is this direction is outward, then this particular transistor is said to be NPN transistor. See, the main purpose of using transistor to amplify the signal, to amplify, as well as it is mainly used for switch also. The amplifier is act as a switch, as well as it is used to amplify the power of the input signal. So this and all here see clearly represent this and all microprocessor, cell phones, motor controllers and all. It's applications part of transistors. So when it was developed, 1947. So who developed? Walter Brattain and William Schottky is developed for transistor. John Burdine, these all three scientists, they developed the first transistor in the world, right? So these are all general applications. So in mic, even robotics, even laptops, even speaker. That also see in all those appliances, also in all those electronic goods, also we are using transistors. That's what that's what I shown. These are all a picture. So next is how the how inside transistor how the doping process or happen. Just I'm showing this. I'm showing this with the help of this semiconductor structure. Just I'm given a small idea. The process of introducing impure elements into semiconductor wafers to form region of differing region of differing electrical conductivity. How inside a transistor, how the electron conduction will happen based on this structure. So doping effects, see, it used to create in a p-type semiconductor, in n-type semiconductor, and the result, see how it will create the doping effects. See, in p-type semiconductor, it used to create a positive charges where electrons have been removed in a lattice structure. In n-type semiconductors, added unbounded electrons. So create a negative charge in a lattice structure. So finally resulting material is p-n junction. So p and n junction. P-type and N-type, so combination of, see this combination of this P-type and N-type, just simply I'm resulting the material, I'm just giving for your understanding purpose, P-N junction. So in P-type, what is the majority maximum positive charges? In the N-types, what is the majority charge? Negative charge. See, this is just here I given a supply biasing I given. So if you give forward bias, see if you give a forward bias, it will see it see the holes and the electron will move like this. If holes and the electrons will move together, then you use to create some region. What is the region name? Depletion region. So once the depletion region will create between this two junction P junction P and N junction, then this depletion layer will form. Then once the layer is formed, then automatically current conduction will flow through this transistor. Same like reverse biasing condition also. See, here forward biasing mean, so keep in mind every one of you positive to negative. Positive terminal to, we have to connect the power supply positive terminal to negative terminal. If it is reverse biasing, we have to see, keep in mind every one of you, we have to connect the power supply. It may be in the form of negative terminal to positive terminal. Okay. Right. Here I see, I'm showing the symbolic representation of NPN transistor and PNP transistor. So if NPN transistor, here see this emitter terminal, we need to keep the direction outward. If it is PNP transistor, we need to keep the see emitter terminal, see this emitter terminal, here the direction is inward. If it is inward, just keep in mind every one of you shortly PNP. If it is direction is outward, then you keep in mind every one of you, this is a NPN transistor. Clear? So types of transistor. So there are three types of transistor: BJT, FET, and power transistor. BJT expansion bipolar junction transistor, FET expansion field effect transistor, and power transistor. These are all symbolic representations. See, FET have a gate, drain, source. See, G means gate, D means drain, S means source. Here in BJT, base, collector, emitter. See, this is a symbol of a tender transistor. The BJT is more, how the BJT will work. Just I'm giving the by it is a sandwiched between the semiconductor layers. The BJT bipolar junction transistor, it is a sandwiched between the semiconductor layers. So it has a three layers: base, collector, and a emitter. Right. So current supplied to this, always the current is supplied to the base. Then so base is the heart of the in a transistor. Base is a heart. So once the base terminal is broken, then current flow never happen in this particular transistor. This is, and see, this is NPN schematic diagram of NPN, as well as PNP transistor schematic. So in PNP transistor, see, holes are majority carrier. In NPN transistor, electrons are majority carriers. See here operating regions. What are the operating regions of a BJT transistor? See, there are three operating regions: cutoff region, linear region, and a saturated region. So always a transistor will work a saturated and a cutoff regions. So keep in mind, friends, every one of you, the transistor, the BJT type of transistor always works a cutoff region and a saturated regions. So on cutoff means off. Saturated means on conditions. So linear region is when it is going for the linear region, the transistor is going to be amplified. Transistor which is used to do amplification process. See, this is see, just for your understanding purpose, I'm giving a small application already I discussed. So the transistor mainly used for switch purpose. This is just like one I made it one with the help of the transistor. Two transistor here I used. So with the help of this transistor, just I made one project. Here I'm just connecting after amplification. See, if you have here, if you across output section, if you connect this any loudspeaker, you will get sound. So then if you give 1 volt input, then here across output terminal by through loudspeaker, you may able to hear the sound energy little bit more. This is BJT, and how the signal, this is a C, this is a green color indicate signal input. So this red color line indicate a signal output. I mean, by using transistor amplifiers, after see, we are getting, if you give a small amount of energy, you will get more amount of output. That is a main advantage of using BJT type of transistors. So that is the reason I given the here waveform representation. This is a field effect transistors symbol. See, if FET basics consists, see, it consists, there are three terminal FET also, gate, drain, source. So here I given, it is a voltage control device. So FET is a voltage controlled device. So here I given, see here very clearly given a comparison between BJT and FET. It is a voltage control device. This is BJT, input current controls output current. The input voltage control output current. Here where in FET. So FET has a three terminal, gate, drain, source. BJT has a three terminal, base, collector, emitter. Don't forget every one of you. Right, fine. So here in FET, gate is a main, so the current flow where it is happen in gate terminal. In BJT, current flow where it happen, base. Right, clear. So current goes out where in collector terminal in BJT. In coming to the point of FET, then current goes goes out across drain terminal. So current comes in across emitter terminal. In coming to the point FET across source terminal. So this is a comparison, very most important point in FET and BJT. So what are the types of FET? We have JFET, MOSFET, IGBT, OF, ET, NO, MEFT. So see, JFET, junction field effective transistor. MOSFET, metal oxide semiconductor. So IGBT, insulated gate bipolar transistor. Organic field, OFET, organic field effect transistor. No MFET, non-particle organic memory FET. So here I clearly given a functions of each and every types of FET, isn't it? See, the JFET uses a reversed biased PN junction to separate a gate from a body. So coming to the MOSFET, user insulator between gate and body. And coming to the IGBT, just similar to the MOSFET, but a different main channel, right? As well as OFET and NOMEF, NOMEFT, Also use organic semiconductor in its channel. Which one? OFET. So at last, no FET is combines the organic transistor, combines this organic transistor and gold nanoparticles. So this is JFET, just a symbolic representation, just I'm given, right? This is in JFET classified. There are two types of JFET. So N channel JFET and P channel JFET. So okay, right. This is see the characteristics and applications of FETs. So it is a very simplest type of FET. You see, can easy to make JFETs. So easy to design. Low capacitance value. So even in switching, it is a slower speed. High input impedance and resistance for using JFETs, right? MOSFET. So MOSFET just similar to JFET, a single channel of a single doped SC material with terminals at the end. So the gate, see the gate here, where is gate? The gate surrounds the channel with a doping that is opposite of the channel, making PNP as well as making PNP or NPN type. But the MOSFET uses an insulator to separate gate from body, while JFET uses a reverse bias PN junction. That is the main difference between JFET and MOSFET. How does a MOSFET work? Here I given a very clear idea with this help of this diagram. See here, there is no current flow. I mean there is no voltage to gate. I mean no current flow. If it is that, I mean this is indicate open circuits. If it is open circuit, no current flow will happen. So if it is a short circuit, then it allows the current flow. This is just characteristics of a MOSFET. This is MOSFET applications. So it used to reduce the power consumption as well as which used to give high input impedances. At last, see the power transistors. The power transistors deliver high power. So compared with BJT type as well as a FET type of transistors, the power transistor will deliver high power, as well as it is used in high voltage and high current applications. In generally fabrication, based on the fabrication process, it dissipate more heat. That is a little bit have drawback, but it avoid breakdown. So different types in power transistor also we have a types. So power BJT, power BJT as well as a power MOSFETs. Okay, thank you friends, thank you for watching. Friends, if you like my channel, if you might like my presentations, please subscribe my channel as well as follow, as well as just you intimate your friends to follow my channel, Sandy Space Puppy. Thank you friends.